In this video, we're going to be going over compound formation, and this is our part 6 video instead of chemistry. And we're also specifically going to talk about the periodic table and how that can help us with compound formation. So let's get started with this video. So first thing is predicting compounds. So the periodic table can actually help us to predict the kinds of compounds that elements are likely to form. So inside of the periodic table, there's 3 different things that can help us to do this, and this is because of the metals, nonmetals, and also metalloids. So there's 2 main types of compounds. One is the ionic compound and another is molecular compound. So ionic compound is where an atom gives or takes an electron, and then molecular compound is where they share electrons. So we're going to look more into that in the next slides, but that's how the periodic table can actually help us to predict the different types of compounds. So patterns of electrons inside of groups. So groups are the columns inside the periodic table, so we can see that there's groups of 1, 2, 3, 4, all the way to 18. So groups are the vertical columns, and then there's also periods, which are the rows. So there's rows 1, 2, 3, 4, and so on until the table ends. So these are groups and rows. So why do elements in the same group have similar chemical properties? And this is because, for example, if you look at the first group, we can see that every single atom in this first group have the exact same valence electron. They all have one valence electron on the outside. And this is why they have similar chemical properties. Because if you have the same valence electron on the outside, that means you have similar chemical properties. So this is why atoms in the same group have similar chemical properties. So now we're going to talk about a stable octet. So atoms in other groups of periodic table tend to react in ways that achieve a stable octet. So this involves gaining, losing, or sharing electrons to fill or empty their outermost energy level. So as we said in our last slide, there's always a valence electron of 1, or some might have 7, and they're all trying to gain a stable octet, which means they all want to have a full outer shell. And to do this, there's a few different ways, one of which is ionic bonding. So inside of ionic bonding, atoms achieve a stable octet by actually transferring electrons. So for example, if we take the case of the first column and also 17, so 1 and 17 groups, usually since 1 has 1 valence electron outside and groups of 17, they have 7 outside. So what they usually do is group 1 shares that 1 electron on the outside and it gives it to 17. So in that case, both of them have stable octets, and then that is the way of ionic bonding where they transfer electrons. And the next one we have is covalent bonding, or otherwise known as molecular compounds. And covalent bonding involves sharing pairs of electrons between atoms so that each can count the shared electrons towards its octet. So for example, we can take O2. So oxygen on the outer shell has 6 valence electrons. So what they do sometimes is 2 oxygen atoms combine together and then they share 2 of the electrons. So since they share 2, then both of them are going to end up having 8 valence electrons on the outside. So this is how atoms are able to give a stable octet, and this is usually through ionic bonding and also through covalent bonding. So this is how they achieve a stable octet. And now we're going to talk about the patterns of electrons. So how can you predict the kinds of compound elements that are likely to form? And there's 4 different ways. The first one is obviously through the valence electrons. The second one is the octet rule. The third one is ionic bonding. And the last one is covalent bonding. So these are how you can predict the kinds of compound elements that are likely going to form. And now for the patterns of electrons. So in groups, the periodic table's organization allows for patterns to be recognized in groups based on the electron in the outermost occupied energy level. So as we said in the first one, since it has 1 valence electron, we know that it's usually going to give the electron, and we know such as 17, they're most likely going to take an electron because they want that outermost shell to be filled. And for example, if we take 18 always has a filled outer shell, so they're not going to participate in anything and they're not reactive at all. And also, just if you didn't know, a valence electron is an electron that is located in the outer electron shell of an atom and thus can participate in the formation of a chemical bond. So electron dot diagrams. So on the right here, these are 2 different electron dot diagrams, and the page introduces electron dot diagrams as a visual to see the valence electron of an atom. So in this case, we have lithium and we also have fluorine. So in lithium, we can see that there's 1 valence electron on the outermost shell, and inside of fluorine, there's 7. So using electron dot diagrams, it can actually help you to visualize to see how many valence electrons there is inside of an atom. And so yeah, as I explained, this illustrates lithium and fluorine, and lithium has 1 valence electron with a single dot in the outer shell, and then fluorine has 7 dots in the outer shell, which means it has 7 valence electrons. So now we're going to finally talk about the formation of ions. So an ion is an atom or a molecule that has a net electrical charge due to the loss or gain of 1 or more electrons, and ions can either be positively charged or negatively charged. So if we look at the picture here, there's 2 different ones, as we said in our previous slide, which is lithium and fluorine. So lithium has 1 valence electron on the outside, and fluorine has 7. So in this case, lithium and fluorine would become an ionic bond, because lithium would give this 1 outer shell to the fluorine. So it would give the last valence electron to fluorine, so then both of them are going to be full. So that means since lithium gave this 1 to the fluorine, that means the lithium would become positively charged because it has more protons than it has of electrons. And on the other hand, fluorine would become negatively charged because it has more electrons compared to the protons. So the fluorine would become a negative ion and lithium would become a positive ion. And cations are basically positive ions and anions are negative ions. In this case, lithium would become a cation, and in fluorine it would become an anion. So as a summary for this video, we talked about the periodic table, valence electrons, electron patterns, and in our upcoming content, we're going to cover over forming ionic and molecular compounds. So that summarizes everything for this video. So thank you so much for watching and try to be useful, and we'll see you guys in our next chemistry video.